All right, good morning, everybody. Today we're going to continue in chapter 2. Last time we talked about what functions, how they're increasing, decreasing, the maximum minimums, and defining piecewise defined functions. Now we're going to look at the algebra functions. Whenever we talk about the algebra functions, when we say the word algebra, what we're talking about are these operations. They're called binary operations because you need two numbers to make them mean anything. And if you think about that, that's what we cover in this course. Everything we deal with is addition, subtraction, multiplication, division in some way, shape, matter, or form. Right? So, for example, here, the algebra functions, what we're saying here is if we have two functions, f of x and g of x, we can add and subtract them. Or we can multiply them. Or we can divide them. That's what we're going to talk about, is this format. But we have to go through the properties first. The sum rule. What it says is this. If I have two functions and I add them together, I could do it one of two ways. I could either add the functions together first and then put my x value in there, or I could find the x values, the values of the functions at the x values, and then add those answers together. And that's what we're going to look at later on this morning. The second, so that's the sum rule. The difference rule is just the opposite. It's subtraction. So we have f of x minus g of x. Then we talk about the product rule. Product means multiplication. If I multiply these two functions together and then put my x in, or I could find the individual values and then multiply the answers together. The fourth one is the quotient rule. Quotient means fraction. So I could divide the two functions first, then put my x value in there. Or I could find the individual values first and then divide the answers. Of course, the restriction we have is the bottom can never equal 0. And the fifth one is not really there, but it's important. It's called the constant multiple rule. If you have, so k is any number, any real number. So if I have k times f, well, the only function's f, k is just the coefficient. That's the same as me finding the value of f of x first and multiplying by the coefficient. All right, let's look what these mean. Let's look at some examples with respect to these. Example 1. Let's say that f of x is equal to x plus 1, and g of x is equal to square root of x plus 3. This is why it's important to memorize as fast as you can or have access to those library of functions we did last week. Because in the very near future, we'll be asked, what about the domain and the ranges of these? So A says, find f of g of x B says, find f plus g of 6. And C says, find f plus g of -4. All right, so let's begin. What this one, first one saying is, I can first take my two functions. That's my f function plus my g function is square root of x plus 3. Or I could take them both individually and separately. So there's nothing we can do inside there, so I don't need the parentheses. Likewise here, there's no coefficient. That's a plus, nothing else. So you see both sides of these things are going to be equal, because that's what the rule says. They're both equal. So now we can plug in some values. So we can either use this side, which says x plus 1 plus square root of x plus 3 when x equals 6. Or we can find f of 6 and then add g of 6 to it. So this one says 6 plus 1 plus 6 plus 3. F of x is x plus 1, so it's 6 plus 1, because my x value is this. And the other one says square root of 6 plus 3. Inside here with parentheses, 6 plus 1 is 7. 6 plus 3 is 9. Square root of 9 is 3, so we get 10. Likewise here, 6 plus 1 is 7. 6 plus 3 is 9. So we got 7 plus 3, which is 10. And it works. So you can choose whatever method you want to do, you can choose your own way, whatever's easier for you. Likewise, this next one, we can do it either way. So this side here is going to be -4 plus 1 plus -4 plus 3 and square root. -4 plus 1, -4 plus 3. -4 plus 1 is -4 minus 1 is 3. -4 plus, since 4 is bigger, it's negative. 4 minus 3 is 1. -4 plus 1 is -3. And square root of -1. Here we have a problem. As of right now, we don't have a solution for us. You can't take a square root of -1 because -1 times -1 is +1, and that doesn't work. And +1, +1. So this one does not exist because we can't do these. Because -4 is not in the domain of g of x. And that's what we're going to talk about next. Domains of the algebra of functions. We have 4 of them. F of x plus g of x, f of x minus g of x, f times g, and f divided by g. Given, of course, g does not equal 0. So for all of these, the domain is where they overlap. In other words, the domain of f, g, and then the domain of g, wherever they overlap. Let's say domain of f was from -2 to infinity. Domain of g was from -infinity to +infinity. So the parts in which they overlap is -2 to infinity. So that's the domain of that function. Plus, for the quotient rule, you cannot use any x that makes g of x equals 0. Those are omitted. So there's some examples here. Example 2. We have f of x equals x squared minus 4, and g of x equals x plus 2. And we have 6 questions. So, but the first thing we want to do here, first thing, find the domains of f and g. So the domain of f, since it's a quadratic function, it looks like this. So it goes from -infinity to +infinity. The domain is all real numbers. I could put negatives in there, I could put positives, and I could put 0. The domain of g of x, this is a linear equation. It's a straight line because there's no powers, no anything. And those go from -infinity to +infinity. All right, so let's look at A. A is asking domains of these. 1, F plus G. Remember, it's where they overlap. This goes to all real numbers. So the domain of F plus G is from negative infinity to positive infinity. Or you could write just that, the R. Similarly, for the same logic, the domain of F minus G is from negative infinity to positive infinity because they overlap. And the same thing for F times G. The domain of F times G is the overlapping of those two. F over G, the domain, okay, it begins with, they're both negative infinity, positive infinity, except where G of X equals 0. So we take G of X, set it equal to 0. So we have X plus 2 So when X equals negative 2, the function equals 0. So we cannot use negative 2. So our domain now changes from negative infinity to negative 2, union negative 2 to positive infinity. Because it looks like this. We have a hole there. We can use everything except that number. All right, so let's look at B. What it says for B, it says find each of the following. So what that's asking us is add the two functions together. X squared minus 4 plus x plus 2. Combine like terms, have x squared, and there's plus x. Negative 4 plus 2 is negative 2. There's f of x plus g of x. F minus g so it's x squared minus 4 minus x plus 2. Typically, you're supposed to put, whenever you substitute, put parentheses around them. I don't need the front parentheses because there's nothing in front of them. And this other one, I distribute through there. So I have x squared minus x. Negative 4, negative 2 is negative 6. There's that answer. No, that's C, I'm sorry. Then comes D. F times G of x. This is f of x times g of x, which is x squared minus 4 times x plus 2. So we got to multiply everything in this first parenthesis to everything in the second parenthesis. So x squared times x, there's 2 there, there's 1 more, so it's 3. They're both positive, so the answer is positive. X squared times 2 is 2x squared. That one's finished. Now the next one, negative times positive is negative. 4 times x is 4x. Negative times positive is negative. 4 times 2 is 8. Nothing combines, so that's as far as I can go. E says f divided by g. We got x squared minus 4 over x plus 2. Right now, it looks like you can't do anything to it. But then in this next chapter and the chapter after that, we'll find out that this top number is actually made up of 2 smaller terms. So right now, this is all you can do. You can't divide. You can't go 2 goes into 4 because these are individual numbers. X squared minus 4 can break down to x plus 2, x minus 2. And the bottom is x plus 2. Okay, so remember, our domain is we can't use negative 2. So when we do this, we'll see that these cancel. So our graph is going to look like this equation, the x minus 2. But with a hole at x equals negative 2, because that's what makes the bottom 0. So the graph will look something like this with a hole in there, wherever x is negative 2. And then f is g times g of x, which is g of x times g of x, which is x plus 2 times x plus 2. X times x is x squared. X times, they're all positive, so it's 2x. That's positive 2x, and that's positive 4. Combine like terms, so we get x squared plus 4x plus 4. And there's our answer. So that's how you combine these functions. Next, we're going to talk about a concept called the difference quotient. Difference quotient is another slope equation. But here's a problem. When we first started talking about slope, which was y2 minus y1, x2 minus x1. So that worked great if we had 2 dots and we connect them, straight line. But this doesn't work to find the slope of a curve. If I had a point here and a point here, and I drew a straight line, that's not the slope of the curve. Whenever you have a graph and you draw a line and it crosses at 2 points, that's called a secant. line. What we need to find the slope of this curve, we need to have the slope of a line that touches the graph at one point. That's called a tangent line. So to find the slope of a curve, we need to find the slope of the line tangent to the curve at one point. Yep, so here we have x1, x2. That's y1, y2. So here's x1, x2, y1, y2. So let's see how we're going to do this. To do this, we start off with our equation. y2 minus y1, x2 minus x1. Remember that a function is the same thing as the y value. So y2 is the function at x2, because it's the x2 value that gives me the y2 value. y1 is f of x1. So remember, we have to find the line tangent to the curve at one point. We can't have 2 points. So what we're going to try to do is we're going to try to move this point closer over there. So we're going to find a point there, find that slope. Find another point, find that slope. Eventually, these 2 points become the same thing. Now, how do we do that? Well, what do we call the distance between x1 and x2? Well, we'll call it h. H is whatever distance it is. So what is it used for? Let's say x1 was 3. And the size of h is 5. If we start at 3 and we go 5 units, then h2 is 8. Or x2, I mean. So x2 is equal to x1 plus whatever h value we have. So anywhere I see an x2, I change it to x1 plus h minus f of x1. x1 plus h minus x1. That's anywhere I see an x2. Let's simplify that. We have f of x1 plus h minus f of x1. The x1's cancel down here, so we just have h. Notice, now all we have is x1. Now we only have 1 point. And h is the distance between the next point. So I don't need to, since I only have 1x, I don't have to put the sub 1 underneath it. Because there's only 1x. This is what is called the difference quotient. So as the value of h goes very close to zero or becomes zero, we get the slope of the line tangent to the curve at any x value. All right, so that's what we're trying to do there. That's our entire goal of this difference quotient part. Let's see how it works. So example 3. We're given this equation. F of x equals 2x minus 3. Use the difference quotient and simplify. Remember, the difference quotient looks like this. F of x plus h minus f of x all over h. We need f of x plus h. Because we're given f of x. We just have to find this. So what that means is anywhere I see an x, I just put an x plus h. So there's a 2, there's an x, so I put an x plus h. And there's my equation for f of x plus h. And plug into the formula. So our formula for our slope is f of x plus h minus f of x over h. So f of x plus h is 2x plus h minus 3. There's the minus sign. Now, since it's a minus sign, whatever comes after it, I put in parentheses. What is f of x? F of x is 2x minus 3 all over h. Now I simplify. I can't do anything inside the parentheses, so I have to get rid of the parentheses. I distribute that 2 to both of those. So I have 2x plus 2h minus 3. Now, this minus will change the signs of everybody inside there. So it becomes that's a positive 2x. It now becomes a minus 2x. That's a negative 3. It now becomes a positive 3. And here's a general rule. Everything after the negative sign, after this minus sign, after we distribute it, everything there has to disappear when we simplify. So negative 2x cancels with the positive 2x. The positive 3 cancels with a negative 3. So we have 2h over h. The h's cancel, And we're left with the difference quotient, which tells us that the slope of the tangent line at any point in this example, since there's no x's, at any point, the slope of the tangent line to the graph is always 2. Now, the reason it's always 2, because if we look at the original equation, this is a linear equation. The slope is always 2. So that's we use those easy ones to check. So, and there's no x. All right, so that's example 3. Let's look at example 4. It'll get a little bit more difficult, the next 2, but it'll cover pretty much any type of examples you can use inside the homework. Example 4. The function is 1 over x. Use the difference quotient. Okay, remember, the difference quotient is f of x plus h minus f of x all over h. We have f of x, we need f of x plus h. So anywhere we see an x, we change it to x plus h. And remember, it stays together. It's one number. It has to stay together. So the difference quotient, which is the slope, of f of x plus h minus f of x over h is equal to this one. It's x plus h under 1. Here's the minus sign. F of x, which is 1 over x, all that over h. So we have our function, we plug everything in there. Now what we need to do, we have to simplify. Look at the top. So we have a fraction on top, and this is actually a fraction on the bottom. But we have an equation. We have this minus this. So we have to combine these two. The way we combine fractions is you have to have common denominators. So the first fraction, the 1 over x plus h, it doesn't have an x by itself. So I got to multiply by x over x. Because I need to get the same, I have to get the same numbers on the bottom. Minus sign. I have 1 over x over here. I don't have an x plus h down here. So I got to multiply top and bottom by x plus h. All that over h. Now here's the question. Why do we multiply by x over x and x over h? X plus h plus over x plus h. Yes, to get the common denominator, but what is x over x? It's 1. X plus h over x plus h is 1. So I'm not changing the function. I'm just changing the way it looks. Any number times 1 is itself. So what's that going to look like? On the top, they both have an x plus h. They both have an x. So the common denominator is x times x plus h. That's the bottom part. Now the top part, we have 1 times x is x, this minus sign, 1 times x plus h over our common denominator over h. So we can't touch that common denominator just yet. We have to fix the top. So we have an x. This negative sign changes both of those. Negative a, negative h. Combine like terms. X minus h cancel. So we have x. On top, we have negative h over x plus h. All that over h. Remember, this bottom number is a fraction. It's x over 1, h over 1. All right, we have a fraction over a fraction. The rule is this. Whenever you have a complex fraction like this, or compound fraction, a fraction divided by a fraction, take the top fraction, leave it alone. Multiply it by the flip of the bottom. And that's the rule we're going to use. So we take the top fraction, leave it alone. Negative h, x plus h, times the flip of the bottom, which is 1 over h. Whenever you multiply fractions, it's like it's one long equation. Everything on top, everything on the bottom. Don't multiply them. When multiplying fractions, reduce first. So can anything on the bottom cancel with anything on top? The h. H goes in h once, h goes in h once. So what we have now is negative 1 times 1 is negative 1 on top. This is a 1, so it's x plus h. As h goes to 0, remember, h is the distance between x1 and x2. As this distance goes to 0, that means x2 gets closer, 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 eventually becomes x1. So as h goes to 0, our difference quotient becomes h goes to 0. So we have x times x, which is negative 1 over x squared. There's my difference quotient. That's the slope at any x. The slope of the tangent line at any point x on a graph. Okay, so that's if you have fractions. It's not really difficult, it's just long. Speaking of long, now we have example 5. Our function here is 2x squared minus x minus 3. Okay, remember it says use the difference quotient which is f of x plus h minus f of x over h. Get used to writing down the formulas over and over so it becomes ingrained in your memory. We have f of x, we need to find f of x plus h. So anywhere we see an x, we replace it with x plus h. So our difference quotient, f of x plus h minus f of x over h, becomes this on top. We have f of x plus, so it's 2x plus h squared minus x plus h minus 3. That's this part. Minus, here's that minus sign, f of x. Now I have to put that in parentheses. 2x squared minus x minus 3. I have to put that in parentheses because there's a negative in front of there over h. Here's the first long part. X plus h squared means x plus h times x plus h. Like x squared is, or 2 squared is 2 times 2, which is 4. So that means I have to multiply these two together. So x times x is x squared. X times h is positive xh. That one's finished. H times x is a positive xh. And then h times h is positive h squared. Because they're all positive, that's why the signs are the same. They're all positive. Whenever you get rid of parentheses, first thing you do is combine like terms. Here's like terms. So that becomes x squared plus 2xh plus h squared. Now this goes in there. So our DQ, difference quotient, now expands 2 times x squared plus 2xh plus h squared minus x plus h minus 3. There's that minus. 2x squared minus x minus 3 over h. That's what I'm saying. See how big it got really quick? Now we got to get rid of the parentheses. We can't do anything inside them, so we have to get rid of them. We have to distribute that 2. So I got 2x squared. 2 times 2 is 4xh. 2h squared. The negative changes their sign, so it's negative x, negative h, minus 3. This negative changes every sign inside there. So from positive 2, it's negative 2x squared. Negative x becomes positive x. Negative 3 becomes positive 3 over h. We got rid of the parentheses, combine like terms. Remember, everything after this minus, all these have to cancel. So this negative 2x squared, positive cancel. Positive x, negative x. Positive 3, negative 3. So just as fast as it exploded, now it shrinks. We have 4xh plus 2h squared minus h over h. Don't cancel anything yet. We first have to, since we notice on top, every one of those has at least one h to it. So I could take out one h. That's all this one's got. That's all that one's got. If I take out one h from the first one, I just have 4x left. Plus 2. I have two h's here. I take away one. I only have one left. I took away this one. There's a 1. Because whenever you factor something out, that's what this is. If we multiply, we should end up with this. So h times 4x is 4xh. H times 2h is 2h squared. H times 1 is h. Now we can cancel. We're giving us 4x plus 2h minus 1. As h goes to 0, that disappears. So my difference quotient becomes 4x minus 1. The slope of any tangent line to the curve f of x at any x. That's what it says. All right, that's it for that section. Let's go and look at section 4 real quick.